x power x, like that. And then we are asked to differentiate this. Okay. What approach are we going to make here? So now we have to remember that this we cannot touch just like this. It will be very difficult for us to differentiate this. So what we do is we apply the natural log. So we're going to apply the natural log on both sides, right? So we'll have something like this. Now you remember the properties. The properties, we said that if I have, let's say I have a power n, and then I apply a log here, okay, that's 10. This is the same as n log a, like that. Okay, this is a property we actually checked in pre-calculus. So now what happens here? What actually happens here is that this will come down here, isn't it? It will come down here. So this will become, so this is preparatory work that we have to do. So this becomes something like this. Okay, now what is the next important step here? We said that, if you remember, when we were doing our calculus, when we were starting, we said that once we do limits and then we understand our rules, the next important skill that we need to have was being able to understand our progression. So for example, in this one here, the first step would be we check what? We check the number of functions that we have. So here we count, we actually identify the functions. Okay, so identify the functions. So how many functions do we have here? We have 1, and then we have 2. Now this has become a function, and then we have 3 here. Okay, so those are our functions, 1, 2, and 3. Those are the functions. So we ID the functions. Then the second step is we're going to identify what? Their relationships, right? So how are they related? This function here, the first one is just singular. This one here, it's just a singular function. These are 2 functions here, right? These are 2 functions. So now we check the relationship. This is singular, so we'll treat it as a singular function. This is a combination of 2 functions, right? So we have 1 function and then that one. So what's the relationship? We can see that these are multiplying, right? Okay, so now we've identified the separate functions or individual functions. The third stage is going to be, now that we've identified the functions, their relationships, what is the best method to apply, right? So here we're going to say that the best method to, so here we ID now the methods based on the identified functions and then the relationships that are amongst the functions, right? So here we're going to say that the best method here is what? Implicit differentiation. And what is the best method this side? We're going to say it's the product rule, right? So now we've identified, we've made the structure, and then we can proceed. So what would be the differentiation here for the product function? Remember, we've just done the logarithmic functions. So the differential for this one is going to be 1 over y using implicit, okay, because that's the differential there. But we don't leave it there. We have to remember that we have to apply dy dx because the x here is implied, it's not there, right? And then here we are going to use the product rule, meaning that we'll differentiate this, it will give us 1. This will not be differentiated, the third function here. So we'll maintain it just the way it is, right? Then what's the next step? The next step is we're going to add. That's the product rule. Revise it if you can't remember. Here we're going to differentiate this one now. But remember, when we differentiate this from the recent notes, we said that this is the differential of this one. You have to remember, okay? And then we're not going to do anything with this one. So we're going to say x, like that. Now, there's something that we can do. We can say this one and that one, they can cancel out so that we get 1 here. Okay? Then we continue. This one will be 1 over y, like that. dy over dx, right, is equal to, this one now will be natural log of x plus 1. So now we can solve for dy dx, dy over dx. We're going to say that this one is going to be y, right? Natural log of x plus 1. Now we can go back and remember that y was actually x power x, right? So now we can bring it here. Okay, we can bring it there. So our final solution is going to be dy over dx equal to, this one becomes x power x. Instead of expressing this one first, we're going to express that one first. So it's going to be 1 plus then x, like that. That will be our final solution. Okay, now we have to remember here, why am I emphasizing that we put 1 here, then the function there? The problem is that sometimes we can make this mistake where initially we had written this plus 1, right? Then we go on and make this mistake in our next statement, like that. These are mistakes that have been made and that must be avoided. So that's why it's better. Even here, I should have expressed 1 first, then the function there. Another thing to note is that this method would have been different if this was a function. But if it's inside here, it's just a variable because it's singular. It doesn't have anything else. So for example, if it was in this form, then our solution would have been a different solution because this is a chained function. All right, so thank you for watching.